Hello, friends, and welcome to the session. We would discuss about prescriptive analytics or data optimization as part of this discussion. We all are already aware of predictive analytics, descriptive analytics, etc. This will be slightly different, and a lot of people will be able to correlate to this as data optimization as well. Even before we get started, let me once again welcome you all to this and welcome to you know, this particular module, wherein we'll talk about a lot of use cases, real world examples, and try to solve this. We have predominantly 4 stages of analytics. Of course, people say 5 stages, 6 stages, etc., but predominantly we have 4 stages. First stage is descriptive analytics. If you have data, say you have data pertaining to sales of different products, and take example of Apple. Why settle for something less? Yeah. Apple as an organization sells iPhones, iPads, MacBooks, so on and so forth. And say you have data for the last, 1000 months. Given this data, if you try to understand what happened in the past until now, did the sales of each and every product that they had increasing, or was it decreasing? Was it increasing in the initial phases? Then was it decreasing? If you try to ask questions on what happened with respect to the sales of different products, right since first month until 1000th month, then it is called as descriptive analytics. If you ask questions on why did that happen, why do you think sales of each and every product was just exponentially increasing and then hitting a plateau, for example, then it is called as diagnostic analytics. Both descriptive and diagnostic analytics talks about what happened in the past until now. Then, if you take the present data and talk about what might happen in the future, then that is called as predictive analytics. What is likely to happen? Would the sales of your products increase, continue to increase, or would it decrease? When you ask questions on what might happen in the future, then it's predictive analytics. But based on your predictions, you might want to probably play around with the business levels. For example, if it so happens that, or if the predictions say that sales of iPhone is going to drop, or sales of iPhone is not going to increase your benchmark, then you might want to increase the marketing spend. That's one of the business levels. Or maybe you want to, look at increasing the production of iPhone, maybe because of iPhone shortage, your sales might be less. Who knows, right? Increasing the number of manufacturing sites could be another business level. Increasing your, sales resources, sales channels might be another business level. So decision makers want these business levels and they want to perform something called as what if analysis. They want to analyze all the different scenarios available and choose one scenario which gives them the best result. That's part of prescriptive analytics. So based on your predictions, what action would you take is prescriptive analytics. And a lot of organizations, service providers nowadays are not stopping at predictive analytics. They're also adding prescriptive analytics. Okay, as a wrapper into their proposals. And that's increasingly becoming one of the key unique selling propositions to win your proposals. Okay. So having discussed these, let's get into prescriptive analytics or data optimization. I'll take the route of, mind map and then help you guys understand more. While there are plethora of use cases which can be solved using data optimization or prescriptive analytics, we would focus our energies in solving network related problems, transportation related problems, transshipment related problems, etc. I'll talk more about those, but even before we get started, here are a few basics. I would say preliminaries, right? A few of the characteristics that one should be aware of. First, you need to understand what is the decision that you want to take. Second, you need to define your objective function, and you cannot meet your objectives in real world business scenarios without any constraints. Constraints would be there from the business standpoint. You will have constraints, and when it comes to constraints, you have at most, at least, and equal to. For now, these are a few things that you need to be aware of. Let's get into the use case, and I'm going to stitch back these three aspects while we talk about the use case. And let me start the first use case here. And this would serve as an icebreaker. While the numbers which are listed down here are made up, fictional, the business problems are not. Okay, so we are doing a project for one of the manufacturing customers, which manufactures pumps, which go into your engine of automobile. And these pumps will take fuel as input from one side, and of course fuel will be output as well, but fuel at a very rapid velocity, at a high speed, which will then make sure that your engine moves, your vehicle moves rather. Here we are talking about this particular manufacturer who manufactures pumps, and two of the prominent customers happen to be Volvo and Daimler Chrysler. Say these pumps go into the truck, and one unit of pump that you produce pertaining to Volvo would give you $350, and one pump which goes into the truck pertaining to Daimler, if you manufacture as a company, you get $300. And say the company which is manufacturing these pumps is called as 360 is the manufacturing company. Okay, just assume. Okay, so 360 is a manufacturing company, and it manufactures fuel pumps pertaining to Volvo as well as Daimler, and per unit price is given. So the decision that we want to make here is how many units of Volvo and how many units of Daimler should you produce, should you manufacture, such that your profits are maximum. It's a common sense thing that, you know what, Volvo gives me $350 profit, so I would as well manufacture all, fuel pumps pertaining to Volvo, because I get straight away, $50 more profit in comparison to Daimler. But that's not how it works, because you are always, constrained. You'll always have certain limitations, right? If there were no constraints, that's a child's play, right? It's going to be an easy task, very easy task, right? Even, if you put this question to your kids, they would probably answer that. One pump is going to give you $350 profit, another pump $300. To maximize profits, what do I need to produce? You just simply apply the greedy approach. You say, go ahead, manufacture only Volvo pumps, right? Okay, so That's not how it works. You'll always you'll always have constraints in the real world. Given this context, let's first look at this part. So what is the decision here? Decision is how many of Volvo fuel pumps and how many of Daimler Chrysler pumps you need to produce. That is your decision. All right. Those two are your decision variables. What is your objective here? Your objective is to maximize the profits. And how do you get this? You look at simply some product, that's the Excel function, of number of units of Volvo fuel pump that you produce into unit price profit. For one pump, I get $350. For two pumps, 2 into this. For 3 pumps, 3 into this. For 10 pumps, 10 into this, right? In that way. And also you're adding that with this, which is number of units of Volvo multiplied by what is a profit per unit. And for Daimler Chrysler also, it's number of units multiplied by the unit profit. When you do this, you come to know about the total profit. Okay, so that's how you look at the objective function. And you want to maximize the profit, obviously, right? In certain scenarios, you minimize, but look into certain business problems where you might also have to minimize the objective function. And constraints. Say to produce 1 unit of Volvo, you need 1 pump, 1 machine, and to produce 1 unit of Daimler fuel pump, you need 1 machine. And you need 9 hours of labor to produce 1 unit of Volvo fuel pump. And you need 6 hours of labor to produce Daimler fuel pump. Then you also need steel. Assume you need some raw material steel. 12 feet of steel rods would be needed to produce 1 unit of fuel pump and 16 feet of steel, maybe steel sheets, if you want to call it that way, right, would be needed to produce 1 unit of Daimler fuel pump. And you only have 200 machines. You have 1566 hours of labor, and you have 2,880 feet of maybe steel plates. Given these constraints, you need to maximize your profits. So here, if you produce 10 units and 10 units, just as an example, 10 machines will be occupied here and 10 machines will be occupied there. So what does that mean? The number of units multiplied by number of machines required plus number of Daimler fuel pumps into the number of machines here. When you add them up, when you do a sum product, that sum product should not be more than 200. It should be less than or equal to 200. On similar lines, number of units of Volvo fuel pump into 9 hours of labor plus number of units of Daimler fuel pump multiplied by 6 hours of labor. When you do the sum product, you get this. This value should be less than or equal to the total available 1566. At the same time, number of units of fuel pump of Volvo into 12 feet of steel plus number of units of Daimler into 16 feet of steel. When you do that sum product, whatever value you get, that should be less than or equal to 2,880. Simple. Right? So these are the constraints. Now, you go to your spreadsheet I'm using Microsoft spreadsheet. You need to go to File, and then you have here the last option is Options. Then you have Add-ins, and here you see Excel add-ins. Click on Go, and please put a check mark on Solver add-in and click on OK. And then what happens is in this data menu on the top, you would have an option called Solver towards the right extreme. Maybe I'll have to close my video for a brief moment. Here, Solver, right? Click on that Solver and Solver would open up. Here, you need to set your objective. What is your objective? Total profits. What do you want to do? You want to maximize them. By changing what? By changing these two, right? So when I click on that, you can select those. Then you have constraints, right? You can add one constraint after another, or you can add all the constraints at one go. Let me remove these and add them one by one, huh? Okay, let me add the first constraint. What is the first constraint? The number of machines used should be less than or equal to 200, which is total available. Okay, so that got added. Let me add another. Then the number of hours of labor should be less than or equal to 1566. I didn't select this as my bad. Okay. Which one did this select? My bad. Okay. This should be less than or equal to this. Okay. All right. Then the total feet of steel material should be less than or equal to the total available stuff. Right. So this should be less than or equal to constraint. Let me click on that and say 2880. Let me click on OK. Done. And here, ensure that you check this option which says make unconstrained variables non-negative. What this means is that you have two decision variables, right? Number of units that you want to manufacture. Number of units that you want to manufacture cannot be negative. So that's why you're putting that check mark. And in the drop-down, you're selecting this particular method, which is simplex linear programming. And then you just click on solve. And here, you see this outline report that won't be checked, friends, but you can put a check mark because you will get sensitivity and other stuff. Let me click on OK now. And wow, it solved the problem for me. And the best solution here is 122 units of Volvo fuel pump and 78 units of Daimler fuel pump is what you need to manufacture given these constraints. And the maximum profits that you can obtain is $66,100. Complete 200 machines which were available were used up. All the hours of labor that was available, 1566, was used up. But out of 2,880 feet of steel plates, not complete, raw material was used up. Only 2,712 feet was used up, right? And then that's the maximum profit that one can achieve. Having said that, let me redo this so as to okay. Let me select the sensitivity report and let me click on OK. So we got the sensitivity report as well here, which has a few things such as objective coefficient, the final values, that is number of units that you need to produce, 122 and 78. Right, and here you have the objective coefficient values, which is the money, profits that you can make. And here you have allowable increase and allowable decrease. So what happens? Let's see, $350, right? Now, if I were to increase $350 to say 360, okay. And then if I click on solver, look at what is the solution of your solver. 122 units of Volvo and 78 units of Daimler. If I try to click on solver and click on solve this, the units will remain the same. So the optimal solution doesn't change. Of course, profits change, but the optimal solution, that is 122 units of Volvo and 78 units of Daimler, does not change. If I change this to 449, and once again, when I try to solve it, it doesn't change the optimal solution. But the moment we go to 450, what happened? It changed. Now it says that, okay, now the optimal solution is different. You just produce 174 units of Volvo because, you know, the price or the profits that you get is going to warrant only Volvo fuel pump to be manufactured. So that's the meaning of 100. So 350 plus 100 is 450. The moment you touch that, the optimal solution changes. So let me get back to 350 here. Okay, now if I click on solver, if I solve it, this is the optimal solution, 122 and 78. Allowable decrease, 50 by 50. If you decrease it until $301, let me solve it. This optimal solution is remaining the same, but if I make it 300, then what happens? Let's see. Optimal solution is the same. If I decrease it any further, 299, now the optimal solution will not remain the same. It would change. Look at that, 80 and 120. So the allowable decrease from 350 was only 50. That's the meaning, friends. And then you have the constraints. These are the constraints, and yep, these are the allowable increase or allowable decrease. So let's change this from 200 to probably 207 and see what happens, or 205 or 201. So if I increase it to 201 as an example, and if I were to try solve that, okay, let me make it as 200 because that was the original available stuff. Let me solve it. Yeah, so this is the optimal solution, 122 units and 78 units. I'll change this to 201. Let's see what happens. It changed. Profits also increase. If I make it 205, what happens? Yeah, again, the optimal solution changed and the profit increased. If I make it 207, again, the optimal solution changed and the profits changed. Now, if you make it 208, does it make any difference? Nothing is changing. Okay, let me make it 210. Would it change anything? No, nothing is changing. So the optimal solution is remaining the same. Just adding more number of machines would not solve your purpose. Of course, your profit has increased slightly as opposed to using 200 to 207. That's a call that you take. How much does it cost you to install one new machine versus the profit that you make? Does it really warrant you to add that additional machine or not? So labor required and steel material required. For that also allowable increase or allowable decrease works in a similar fashion. So 200 plus 7 minus 26, 200 minus 26, that is a range in which your optimal solution keeps changing. But if you go, sorry, I disabled my camera. If you go and select a number which is less than the allowable decrease, or if you go and select a value which is beyond allowable increase, it doesn't work. Okay, or it won't change the ultimate optimal solution and the objective value. All right, so this is a quick discussion on part 1. Absolutely, we'll discuss more as we proceed further.